Now, the next kind of energy that we have to see is bioenergy. When you talk of bioenergy, what is bioenergy? So, bioenergy is the energy of biological origin derived from biomass such as fuel wood, livestock manure, municipal waste, and energy crops. What are energy crops? Energy crops are the crops specifically cultivated to provide bioenergy, mainly biofuels. Now, this bioenergy can be created from anything from plants to straw to slurry to food waste and even sewage. So, when these materials are being used for their energy content, they are referred to as feedstock. So, one term that you will very often see whenever talking about biofuels is feedstock. So, the very first thing that we should understand from the point of view of bioenergy is biomass. So, what is biomass? Biomass is biological material derived from living or recently living organisms. In the context of biomass for energy, this is often used to mean plant-based material, but biomass can equally apply to both animals and vegetable-derived material. Many of the biomass fuels generate lower levels of such atmospheric pollution such as sulfur dioxide, which is one of the advantages that is associated with biomass. Then the use of biomass fuel provides an economic incentive to manage woodland, which improves biodiversity. So these are some of the advantages associated with biomass. What is biomass? Biological material derived from living or recently living organism. Now, how does biomass generate energy? See, this actually depends on the type of biomass that is being used. First, the dry combustible feedstock are burnt in the boiler or furnace, while the wet feedstock are put into sealed tanks where they create biomethane gas as they rot. Now, this gas is captured throughout the rotting process and then it is burned. The burning of the biofuel or biomass, produces heat which can be used to water. Now, the burning of biomass or biomethane produces heat, and this heat can be used to warm homes, shops, offices, or can be used to drive steam turbines to generate electricity, much in the same way as coal or gas-fired power plants do. Now, next question can be, is this a form of energy which is environmental friendly or sustainable? So, while the burning of biomass will release greenhouse gases, there is no doubt about that. If you look at the entire cycle of bioenergy, it can be zero carbon and sustainable source of energy. But how is this possible? How is zero carbon and sustainable source possible? The answer depends on whether the waste feedstock or energy crops are being used. This depends on whether waste feedstocks or energy crops are being used. The waste biomass gives off gases naturally through the rotting process. Now, if this happens in the absence of oxygen, such as when buried deep in the landfill, it creates methane, which is very damaging greenhouse gas. Instead of allowing the methane to vent into the atmosphere, the bioenergy process captures it and burns it. This converts it into carbon dioxide and water vapor, which is much better for the environment. Also, using the energy from burning biomass reduces the need to extract and burn climate damaging fossil fuels. Energy crops are different, as they are produced specifically to be a source of bioenergy. So, unlike the waste, the argument that burning them produces greenhouse gases which would have been given out anyway is invalid. But the energy crops can still be low carbon as long as they are from sustainable sources. So, you can say that when the energy crop is burnt, an equivalent crop should be grown to absorb the same amount of carbon as was released by the burning. And when this new crop is burnt, even this should be replaced, and this should be a process, a cycle that should go on. So this is what happens with the case of biomass. So what is bioenergy feedstock? What is feedstock? We have already discussed. So these are some of the feedstock for bioenergy. First is wood. One can be the forest management residues. The second can be the fuel timber. Then from the crops, either it can be cereals, oil seeds or sugar beet, or the perennial crops such as miscanthus, reed canary grass, short rotation crop and short rotation croppice. Again, from the waste, it can be animal manure or it can be straw. So all these can act as bioenergy feedstock. Now, the next thing that we need to discuss is what do we mean by biofuels. So if you look at this definition, any hydrocarbon fuel that is produced from organic matter in a short period of time is considered as biofuel. So see, from organic matter, your coal and petroleum is also being produced. But it doesn't happen over a short period of time. Look at this. We are looking at just days, weeks, or maybe months. But when you talk of coal, you are not just talking about a few days or a few months or a few years. You are talking about a million of years. So that's why you cannot compare the two. Again, if you look at the sources of biofuel, they are produced from biomass, usually of agricultural origin. So it can be bioethanol, it can be biodiesel, it can be biogas. So what happens is, so this is what biofuel is. Now one important thing that you need to know about biofuel are the biofuel generations. So there are 4 generations of biofuels that we talk of. First generation biofuel, the second generation biofuel, third generation and the fourth generation. So the biofuels are broken down into generations, and mainly there are 3 categories, or you can say 4 categories: first, second, third and fourth generation. So if we talk about the first generation biofuel, we already know that many plants contain high energy organic matter that is life bound of any type of renewable biofuel. The biofuel sector began positively appropriating this knowledge by producing renewable fuel as a counterpart to the dominant fossil fuel industry. And this first kind of biofuel production was termed as the first generation biofuel. So what you can say in simple terms is that first generation biofuels are those which are made from feedstock that can also be consumed as human food. So for the first generation, the feedstock that you have is something which can be consumed by humans as well. So you can talk about sugar, you can talk about starch, you can talk about vegetable oils. All of them are human food products which make them the first generation fuels. So the typical feedstock that the feedstock that typically top the list of this first generation biofuel, it includes the food crops like, let's say, maize or sugar cane, sugar beet, wheat, or let's say, now the human food, as we all just talked about, that actually creates the feedstock for first generation biofuel are some of the food crops like corn, sugar cane, sugar beet, wheat, all these kind of things are there. So this is what the first generation biofuel is. Now see, what happens is, since they are easily extracted using conventional technology, they are also called as conventional biofuels. Now there are 2 kinds of fuels which we have to discuss while discussing the first generation biofuel. The first of it, now if we have to discuss the first generation biofuels, there are 2 kinds of first generation biofuels that you need to study. One is biodiesel and the second is bioethanol. So how are they produced? If you look at this flow chart, this will give you the complete picture of it. So if you have vegetable oils, for example rapeseed oil, sunflower oil, etc., which is the feedstock being fed with esterification, and if the esterification is happening, it would lead to the formation of biodiesel. Then for the production of bioethanol, we start with sugar crops or starch crops, and then they undergo the process of fermentation, finally leading to the formation of bioethanol. So now biodiesel basically can be blended with or can replace diesel, and when it comes to bioethanol, it can be blended with or it can replace petrol. So these are the two important first generation biofuels. Now another kind of biofuel that we should discuss here is biogas. And how is biogas being produced? It is being produced by anaerobic fermentation of organic waste and crop residue as energy crops. So what is anaerobic fermentation? Fermentation that is happening in the absence of oxygen. So when that happens for organic waste and for crop residue, in that case biogas formation happens. Now what happens is, when you talk of first generation biofuels, they have a number of problems that is associated with them. Now the first debate that we have here is that whether they have a benefit in reducing greenhouse gases and carbon dioxide emissions, due to the fact that some of the biofuels can produce negative net energy gains. They can produce negative net energy gains. What do we mean by negative net energy gains? Is the fact that they can release more energy in their production than their feedstocks capture in their growth. So the amount of carbon capture that is happening, the release of carbon that is happening in the atmosphere is more than that. So that becomes one of the factors that is associated with it. Then another important factor that is considered when you talk of first generation biofuels is the food versus fuel factor. So if you look at this diagram, from the point of view of food security, the first generation biofuels are not seen to be very good. For example, these crops are now have to compete for food or for biofuels. So this, what can happen is, as majority of the biofuels are being produced directly from the food crops, there can be a rise in demand for biofuels, and this can lead to an increase in volume of crops being diverted away from global food market. And this has been actually blamed for the increase in the food prices globally. So this is one dilemma that is associated with the biofuels. So there are four factors that we should consider while talking about the food security part. The first is the availability of food versus biofuels. So if you look at this point, the production of genetically modified crops will be encouraged, aimed to biofuel industry instead of food consumption. This can be one problem that you might face. Then there will be a decrease in food import capacity, especially in the poorest countries due to increase of prices. Then there can be a decrease of food aid, since the cereal stock will be diverted towards biofuel production. Apart from that, when we talk about the access to food versus biofuel, the biofuel production causes increase of food prices due to increasing demand for agricultural products. The current influence of biofuel on food prices range from 3% to 30%. So biofuels actually have a influence on the food prices. Then the next aspect that we have to see is stability of food and access to food versus biofuel. So the first point, if you look at here, the food and fuel crops compete for land and water resources, and this may also lead to increase in their prices. Then the increase in the price of land leads to the next is the fact that the increase of price of land leads towards is concentration, right? So there what will happen is, so what can happen is that small farmers can turn into waged workers and they can lose their food sovereignty. Then finally, the subsidies and tariffs on biofuel affect stability and access to food and cause distortion in the food prices. Another point we have to look at is food utilization. So the increase in demand of fuel crops may lead to a lower food quality and diversity, and this would threaten the nutrition of people. Then again, the water availability of for human consumption will be threatened, because producing 1 gallon of corn ethanol requires consumption of 170 gallons of water, and producing 1 gallon of soybean based biodiesel requires the consumption of 900 gallons of water. So if you look at all these factors, food security is the main reason why first generation biofuels are not considered to be a good source of bioenergy. But let's look at some of the factors which are advantageous as a case of biodiesel. So biodiesel first of all reduces carbon dioxide exhaust by up to 80%. Biodiesel produces 100% less carbon oxides than petroleum. And these advantages of biodiesel that we are talking about is with respect to diesel. So the first is the biodiesel reduces carbon dioxide exhaust emissions by up to 80%. It produces 100% less sulfur oxides than petroleum. Then biodiesel reduces exhaust smoke by up to 75%. So the usual black cloud that is associated with diesel engines, that will not be the case with biodiesel. Then it is easier to handle and does not cause cracking or redness. Another important point. Then biodiesel is much less dangerous to put in vehicle fuel tank, as the flash point is 150 degrees Celsius as opposed to normal diesel, for which it is 70 degrees Celsius. So it will not catch fire or it will not have combustion as easily. And then finally, it provides significant lubricacy improvement over petroleum diesel fuel, so engines last longer. With the right additives, engine performance also can be enhanced. So these advantages are associated with biodiesel. Then another source for biodiesel is a plant known as jatropha. So jatropha can be cultivated anywhere along the canals, roads, railways, and border of farms, and even alkaline soils. If you remember, when our former Prime Minister Dr. APJ Abdul Kalam, when he was in office, he had set up a land for jatropha cultivation back in 2004. But after that, what happened in the last few years, what has been seen is that jatropha now is not considered to be a very good source of biofuel. So that's why what you'll see is that biodiesel is not very much being considered to be produced from jatropha plant. But 10 years ago, you can say, or 15 years ago, it was seen as one of the huge potentials as well as biodiesel is concerned, but not anymore. So if you look at how jatropha is being converted to biodiesel, first you have to take methanol. From methanol, in methanol, jatropha oil has to be added. 1100 kg of jatropha seed will produce 30 kg of jatropha oil. From here, 3 kg of glycerol and 30 kg of biofuel or biodiesel will be produced. So this is one of the reasons why jatropha is not considered, because the amount of biofuel that is being produced is very less. The amount of jatropha seed that is going in for processing and the amount of biodiesel that is being generated or extracted from the jatropha seeds, that ratio is not very good. And that is one of the reasons why jatropha was not considered to be a very good source for production of biodiesel. Then talking about bioethanol, some of the facts about bioethanol. First is the fact that Brazil is the first in terms of biofuel consumption in bioethanol, and the fact is that since 1970s Brazil has been using it. Then again, according to UNCTAD, Brazil uses more ethanol in 20% of their vehicle and 22 to 26% of ethanol petrol blend in the rest of their vehicles. Now, according to one report, Brazil uses pure ethanol in 20% of their vehicles and a 22 to 26% ethanol petrol blend in rest of their vehicles. The carbon monoxide emission from automobile decreases from 50 gram per kilometer in 1980 to 5.8 gram per kilometer in 1995. This has happened because of bioethanol. The USA and Australia use a 10% ethanol blend. India is the fourth largest producer, and the government mandated the use of a 5% ethanol blend in petrol sold in 9 sugarcane producing states. So these are some of the facts with respect to bioethanol, another kind of first generation biofuel. Then if you look at these points, bioethanol is a form of renewable energy that can be produced from agricultural feedstocks. It can be made from very common crops such as sugarcane, potato, cassava and corn. The concerns about its production and use relate to the increase in food prices due to the large amount of arable land requirement for crop, as well as the energy and pollution balance of the whole cycle of ethanol production. Recent developments with cellulosic ethanol production and commercialization, but the recent developments, if you look at cellulosic ethanol production and commercialization, may allay some of these concerns. Then what is this cellulosic ethanol? So cellulosic ethanol offers promise because cellulose fibers, a major and universal component in plant cell walls, can be used to produce ethanol. So these are some of the facts related to bioethanol. Then coming to the third aspect, which is biogas. Biogas typically refers to the gas produced by breakdown of organic matter in the absence of oxygen. It is a renewable energy source like solar and wind energy. Biogas can be produced from regionally available raw materials such as recycled waste. Biogas is produced by anaerobic digestion with the anaerobic bacteria of biodegradable materials such as manure, sewage, municipal waste, green waste, plant material and crops. So these are few of the facts with respect to biogas. So if you look at this diagram, this is how the production of biogas happens. So if you look at this part, there is a slurry tank, there is a solid material feed hooper, which is all going into the gas holder, and from there it is going to the digester. So if you want to briefly understand how biogas production happens, these would be the sources for you for the biogas. The distillery will provide the effluents, the slurry tank and the solid material feed hooper will go into the slurry tank, and from the slurry tank it will go to the slurry where anaerobic digester will help in the production of biogas, and this is the gas holder where biogas is being held. From there it goes to the digestate. The gas holder goes for the generation of power, and from the power plant the generation of power or the electricity supply for the power grid is happening. So all the additional heat gets recovered here, and then finally it can be used again. From the digester, the biofertilizer is being carried to the different parts wherever you want to. So this is how a simple biogas plant works. Now biogas basically comprises of methane and carbon dioxide and may have small amounts of hydrogen sulfide and moisture. The gases methane, hydrogen and carbon monoxide can be combusted or oxidized with oxygen. This energy release allows biogas to be used as fuel. Biogas again can be used as a fuel in many countries. Again, biogas as a fuel can be used in any country for the fuel or the heating purpose. And then finally, it can also be used in gas engines to convert the energy in the gas into electricity and heat. So if you look at the composition of biogas, these are the major components that are present in the biogas: methane, carbon dioxide, nitrogen, hydrogen sulfide and oxygen. So majorly, that's why what we were saying is that these are the major components of biogas: methane and carbon dioxide. Apart from that, all the others are going to be present in very small amounts like 0 to 10% nitrogen, 0 to 1% hydrogen, 0 to 3% hydrogen sulfide, and very small amounts of oxygen. So the most important gases to remember are methane and carbon dioxide. Now, why do we use biogas? What are the advantages that are associated with biogas? The first is that it can potentially help to reduce global climate change. Normally, the manure that is left to decompose releases two main gases that cause global climate change: nitrogen dioxide and methane. Nitrogen dioxide warms the atmosphere 310 times more than carbon dioxide, and methane 21 times more than the carbon dioxide. So by converting the cow manure into methane biogas via anaerobic digestion, the cows would be able to produce huge amounts of electricity. So the cows are producing electricity for us, and that's why we have to make use of all these kind of waste for production of biogas. Then if we look at some of the facts with respect to India. In India, the biogas production from anaerobic digestion of manure is small scale digestion. So in India, the facility where this production of biogas is happening is known as Gobar gas plant. It happens at Gobar gas plants. The digester is an airtight circular pit made of concrete with a pipe connection. The manure is directed to the pit, usually directly from the cattle shed. The pit is then filled with a required quantity of wastewater. The gas pipe is connected to the kitchen fireplace through a control valve. The combustion of this biogas has very little odor or smoke. So, owing to the simplicity of the implementation and use of cheap raw material in villages, it is one of the most environmentally sound energy sources for rural needs. So these are some of the facts about first generation biofuels, especially biodiesel, bioethanol and biogas. Now from the first generation biofuel, we need to move into second generation biofuel. What do we mean by a second generation biofuel? So very much like the first generation biofuels, the second generation fuels are also produced from sustainable feedstock, but one difference is that in this case the feedstocks are not normally used for human consumption. That is, no second generation feedstock is also a food crop, though certain food crops may become second generation feedstocks if they are no longer being used for consumption. So second generation non-food feedstocks can include woody crops, agricultural residue, waste, or waste which are little more difficult to extract. So for this reason, the advanced conversion technologies are needed in the process, which is also why you can say the second generation biofuels are also known as advanced biofuels. Now, the second generation biofuels are also aimed at being more cost competitive in relation to existing fossil fuel. The life cycle assessment of second generation biofuel have also indicated that they will increase the net energy gains, overcoming another, which you can say is another overcoming of the first generation biofuel limitation. So because of these factors, second generation biofuel is seen to be a better variant, a better kind of biofuel. Then comes the third generation. So when we talk of the third generation biofuel, the keyword that you should remember for third generation biofuel is algae. That we are making the use of algae for third generation biofuel. So the third generation biofuel is based on improvements in the production of biomass. It takes advantage of, you can say, specially engineered crops such as algae as its energy source. Now, algae's use in biofuel production was formerly relegated to second generation, but there exist some key differences that have been warranted, and that's why it has become its own separate category. Now, what are these advantages? What are these differences? First is that the algae are cultured to act as low cost, high energy and entirely renewable feedstock. algae can also be grown using land and water unsuitable for food production. So therefore we are reducing the strain on already depleting water resources. Again, algae is capable of producing much more than its other feedstock counterparts with very low resource inputs also. So there are some estimates which say that algae can produce tenfold of what the ever, some of the estimates what they have said is that algae can produce tenfold of what even the best conventional feedstock can generate. The capital and the operating cost of the third generation production are also the highest. So that's why we say that the third generation biofuel require research and development to reach a point of being sustainable method of consistent biofuel production on a commercial scale. But the potential is very highly promising, and that's why we consider the third generation biofuel. And it's not only that, you can also consider other factors. For example, jatropha. If you want to use jatropha as your biodiesel production feedstock, jatropha would take, let's say, 10 years to build up, probably 5 years to give you a proper amount of seed that you need. But compare that to algae, algae grow very fast. So that's why the production of energy that can happen through algae will also be very fast. So that's why it becomes a faster source of biofuel for you compared to any second generation or first generation biofuel. So that is another kind of advantage that is associated with third generation biofuel. Another advantage that you can talk of, that amount of energy that is being produced with the amount of algae that is used as input is also very, very high. So that's why with very less input you are having very good output. So that's why third generation biofuel has some more advantages associated. Then you have another generation which is the fourth generation biofuel. Now the fourth generation biofuels are aimed not only at producing sustainable energy but also as a way of capturing and storing carbon dioxide. The biomass material which have absorbed carbon dioxide while growing are converted into fuel using the same processes as the second generation biofuel. So, but this process will differ from second and the third generation production, as at all the stages of production the carbon dioxide is captured using the processes such as oxy-fuel combustion, and this would reduce the amount of carbon dioxide because the carbon dioxide is being captured. So now this carbon dioxide then can be geosequestrated, the process which is called as carbon sequestration, by storing it in old oil and gas fields or saline aquifers. So this carbon capturing makes the fourth generation biofuel production carbon negative. It makes it carbon negative. So that's the huge part about the fourth generation biofuel. So when we talk of the second or the third generation biofuel, we talk that they are carbon neutral, that the amount of carbon that they are taking it is same as the carbon output that they have. So they are carbon neutral. But in this case, when you talk of the fourth generation biofuel, they are carbon negative. That means that the amount of carbon that they take is lesser than the amount of carbon that they produce. So they, you can say in a way, they become a sink for the carbon. So that's why you can say that it locks away more carbon than it produces. So this system not only captures and stores carbon dioxide from the atmosphere, but it also reduces the carbon dioxide emission by replacing the fossil fuels. So that becomes one of the most important advantage that you have with fourth generation biofuels. So when we talk about the examination, remember that the biofuels are going to be the most important part of your examination compared to all the other things that we have discussed. So make notes of all the things that we have made here. It will be very, very important for you.